For the first time in over 50 years, humans have left the immediate neighborhood of Earth and ventured back into deep space. This mission trajectory targeted the uncharted far side of the Moon, positioning the crew to witness phenomena humans have never directly observed, such as real-time meteor strikes against the dark lunar landscape. Artemis II was engineered specifically as a high-stakes reconnaissance flyby. It pushed a brand-new spacecraft and its crew to the limits of their endurance, isolating them from any possibility of a rapid return or ground-based assistance. Before we can safely put boots back on the lunar dust, we have to prove our life support, and navigation systems can survive the radiation and hardware stress of deep space for days on end. Since 1972, crewed flights have stayed within low Earth orbit, a zone where an emergency return to the surface takes only a few hours. Artemis II moves past this threshold, placing the crew several days away from any possible rescue. The crew traveled nearly 252,000 miles from Earth, placing them behind the Moon, completely out of sight. This extreme distance tests the foundation for future deep space travel. Sustaining a crew here provides the essential data required for the multi-million-mile journey to Mars. By severing the tether to low Earth orbit, spaceflight shifts from short-term scientific visits to the long-duration operations required for permanent outposts. As the spacecraft curved around the lunar far side, the physical mass of the Moon blocked all radio signals. The crew entered a total communications blackout, relying entirely on their onboard systems. The Moon's near side is defined by smooth, dark basaltic plains called Maria. In contrast, the far side, which the crew directly faced, is a densely cratered and violently scarred terrain. This topographic map reveals the immense scale of scars like the Oriental Basin. Deep red and blue zones indicate massive impact structures. We also see the Hertzsprung Basin. With no atmosphere, craters experience zero erosion. Every ridge remains sharp. Mapping this untouched topography is a requirement for future landings. We must identify these topographical extremes to select safe, viable locations for permanent base camps. While navigating this darkness, the crew observed something rare. 6 live meteor impacts happening in real time on the lunar surface. The Moon has no atmosphere to burn up incoming cosmic debris. Without that shield, every incoming rock strikes the surface at full kinetic velocity. The time-lapse evidence is visible here. The red arrows point to the sudden bright bursts of light as the meteors strike the dark terrain. These silent collisions happen sequentially on the Moon, but having a human crew in position to witness them provides rare direct observation of the lunar environment's volatility. Documenting these live strikes provides hard data on the kinetic energy bombarding airless worlds. This information helps engineers determine the protective requirements for deep space habitats and future Martian shelters. As the spacecraft continued its arc, the crew captured this view: Earth slowly rising over the gray, ancient horizon of the Moon. Seeing the planet as a fragile blue sphere floating in a void triggers the overview effect, a psychological shift that emphasizes Earth's fragility and the unified nature of humanity. From this vantage point, the crew also witnessed a solar eclipse. Seeing the Moon cast its shadow onto Earth from deep space highlights the flawless mechanical alignment of the solar system. While charting the far side, the astronauts identified previously unmapped geological features, proposing the names Carol and Integrity for these ancient craters. Assigning human names to this landscape integrates these billion-year-old structures into the mapped territory of human exploration. The legacy of this flight also includes a shift in crew composition. This mission broke the demographic mold that defined lunar exploration 50 years ago. For the first time, this mission included a woman, a person of color, and a non-American astronaut. This diversity establishes a collaborative baseline for international space exploration, moving beyond the national competitions of the past. The mission establishes the Moon as a functional, operational gateway to the rest of the solar system. Testing life support resilience and documenting deep space hazards at this distance provides the foundational data required for the much longer journey to Mars.